October 9th, 2013. As we're looking at some amazing images from the SDO from the last 2 days, you saw the first half of this in the video yesterday. Now, as that filament comes down and touches again in the middle of the sun, notice that release and that shadow go across the sun. Well, that created the CME that's approaching the sun. Now, also, during this time, we had a solar flare, not a coronal mass ejection, but a solar flare. And it was from the same side of the sun, but on the bottom half. And I'll show you that. This is a close-up of the annual solar wind prediction. You notice just before the 10th, that's midnight tonight UTC time. So late this evening, we should see a somewhat of an impulse. But I'll show you the K-index and explain it. Now, here's where we had the stronger flare. See that? It was not an X flare. It's not showing up as an X flare. But it gave a strong pulse, and you notice that reaction around it from the filament behind it. Now, all of this is happening as the comet, it's a small comet, has approached and now has come in contact with the sun. We'll go through that. Again, here on the images, this one will allow you to see that flare a little better. I'm going to stop it. Now, it gave a pretty good impulse to the camera at that time, but it seems that after a period of the sun being quiet, that it's picked up in the last 48 hours. Again, we've had 3 major events that I call major events. It's the strongest flare in 2 months and 2 of the strongest CMEs that you'll ever see. Hope you don't see them much stronger than that, especially on the Earth-facing side of the sun, like we're looking at now. But here I've got it paused right at the strong flare. And you can see it impulsed enough to overexpose the light and the hot spots all the way across the sun. But again, we're getting it seems to be waking back up. We've got 2 nice sunspots, one coming around that's crackling with small flares that released this flare. I'll show you on the solar disk. But again, you can see the chain reaction of events. There's the large sunspot, that's 1865. It was an M28 class eruption. Now notice also in the top, Space Weather Radio is back on. They got some donations, and you can go in there and listen to the meteorite hunters. I'll put a link to that site. But it pings out of Texas as a meteorite or an asteroid comes over. This is the K-index out of Boulder. Notice that it's up at 5, and if you look at the chart in the bottom, that tells you how far south you can see the auroras. Last night they were so strong they turned red again. If you look on spaceweather.com, they've got a section where people send in the photos each day from the auroras that night. And again, second time in a week that they've been red from these strong pulses. Again, first time from that solar eruption last Sunday that we saw the big CME whip off just like this one. Now here, what it did, it caused that wind speed. The solar wind speed went from 325 kilometers a second to 700 kilometers per second there. So it definitely picked all of those events up, the temperature and the density. But that solar wind speed jumped. And here, again, strongest flare in over 2 months. Notice right above that, that's not far from the X flare range. Now, we've been looking for 48 hours at this pulse. These are the normal readings that you're going to see on this SIS chart from ACE. This is what's been going on for 48 hours, and these are some of the questions and comments that have come on the channel. Is it coming from the sun? Is it the outer solar system? Because ACE can pick up galactic signals. Or is it a heart bounce? Or is it signaling a magnetic pole shift of the sun? I noticed there's about 1 hour increments in these heartbeats or these pulses. Now, I updated this just as I was finishing the video. I went back and looked at this chart after the comet strike, and look. We've had 3 large solar events during the 48 hours of this pulse, and that's as that small comet approached. Now, look, right here at the end of the video, that it went back down. So what's a larger comet going to do in this period of this solar cycle? That has everything to do with it. All comets come at different times when you've got a low in your solar maximum into your solar minimum, but we're supposed to be at that peak of this solar maximum. So we're going to have to watch it. Again, look at your magnetometer here. That affects your magnetopause. And there were quite a bit of compression shots on that. Now let's look at this comet coming in. This is during the period of those pulses on the SIS. Again, these are LASCO C3 Earth-facing images. I'm going to show it to you on the LASCO 3 and the LASCO 2 cameras also, but there's that comet coming in. It appears to dissolve away, but that's not what's going on. This comet strikes the sun, and we have two events after the strike, one major one or two possible major events right before the strike. That's before the strike there. That's one from yesterday's video that you saw. Here comes our comet. Watch it. I'm going to show you a couple things. And I was expecting this before I went in and checked it. To be honest with you, I've seen it too many times. Now again, the white circle is the size of the sun. Here comes your comet. Notice your timestamp is at 1700 hours UTC time. That shows the 10th. It shows the 8th. That was, and we saw that yesterday. Now there's a 2 hour and 48 minute skip in the pictures there. Now after that, it goes back to about 2 per hour. It was doing that before. And it makes you wonder, does NASA not want to have to rewrite all the science books on the dirty snowball comet theory? Because that comet's traveling at about 7 million miles per day when it gets that close to the sun. You can check that, look at your iSun 3D charts. Now that it's traveling 2 million miles a day, it will increase in speed up to 7 million miles per day as it approaches the sun. But with that pulse going back down after that comet strike, it's going to be an interesting time to watch this comet come in and other comets during the solar peak. Heads up.